All right, just to review things that you guys have learned in the past. The first question, if you were asked to solve x minus 9 equals 4, what would you do to solve that equation? Jackson. You were going to add 9 to both sides, right? Now, how do you know this symbol that I'm writing means to add? How do you know that symbol means to add? How do you know? You were taught that. And you've just used it so much that you don't even have to think about it anymore. You know, if you see that symbol, you have to do addition, right? I know, that's such a silly question. Like, I don't know. I just always known it. No, you haven't. At some point, you didn't know what that meant. I don't remember not knowing what that meant, but I have a daughter who I've shown that symbol to, and she didn't know what it meant. She now does, but she didn't know what it meant. Okay, how about the next one? 6x equals 17. What would I do, Nina? I would divide by 6. Nina, how do you know what the symbol means? That's what you were taught, and you've just done it so many times that you just know that that means division. Also, the fraction bar itself means division. The fraction bar literally is the division symbol. That's what they did. They made the division symbol up by saying this is a blah fraction. Like that's how they made the that's how they made the division symbol up. Don't know if you knew that, but it's pretty cool. Okay, the third one. X squared equals 25. How could I get x by itself for that? Somebody new. Who's talking? Yes, Ella. Square root both sides. All right, Ella. I got a question, though. There is something else that I need to do when I square root. Do you know what it is? Yeah, plus minus. Okay. Ella, how do you know that symbol that I drew just now means to square root? You were taught it. Also, how did you know I was supposed to square root? Like, how did you know that? I couldn't hear that. Can you louder? It's squared, but, well, how do you know that means to use a square root? Because you were taught it. Like, all of these things, that's the answer every single time. Like, you were using it so much that you just remember this stuff. If you do something repeatedly, it becomes long-term memory. Okay? If you stop doing it, your brain decides, I don't need that information anymore, and it gets rid of it. Did you know that? Like there's these little dendrites that your brain creates when you make new connections. And if the brain says, this dendrite is never being used, it goes, throws it away, plucks it off. Did you guys know that? That's why, like, when you don't have school for 3 months and you come back and you're like, I forgot all of math. It's because you didn't use it. Anyway, so we would have plus minus 5. All right, my fourth question. I need to get x by itself. How can I get x by itself? Uh-oh. Did I stump you? Brooke, do you know? What? So, you know this is a exponent, right? Okay, so if I divide by 2, I'm going to get an answer of 9/2. Let's check that. 2 to the 9/2. Here, I got a calculator open. 2 to the 9/2. Nope. It's 22 point something. So I can't divide because 2 is not being multiplied by the x. Thank you for trying something. Ashlyn? Like x root? Okay, so if I x root, got to do it to both sides. That's going to cancel the x power and you're going to get 2. But how do you do the x root of 9? We could write it maybe as 2, and we could change the root into an exponential rational exponent where I would do 9 to the 1 over x. But now we have the same problem. We still have the x in the exponent. You're not going to be able to tell me the answer unless you've learned this lesson. This is what's new today. Okay? Now, it's new. So it's not going to come as natural as the first 3 examples because it's new. You haven't done it for years and years and years. All right? But we're going to do it a bunch, and then it'll become more natural to you. This is what we're doing today. Okay? I will show you how to do it here, and then you don't necessarily have to write this down if you're not writing it down already, but we'll do plenty of it in the notes for today. So I'll show you what our lesson looks like today. The inverse operation to get 2 out of the picture and get x by itself is called doing a logarithm. Okay, it's called a logarithm. A logarithm, or just log for short. All right, what I'm going to do is I'm going to logarithm both sides. And you have to have a specific logarithm. This logarithm I'm using has a base of 2. And so I put this tiny little 2 down there. And again, if you're not writing this one down, we're going to do it many times in our work today. I just want to show you for the first time here. If I do that to one side, I have to do that to the other side. Okay, so I'm doing something to both sides, and that something that I'm doing will cancel out the base of 2. Just like everything else was an inverse and canceled out what was there, this cancels out a base of 2 and leaves me with x by itself. On the other side, I only have numbers. The word log is just it's like a symbol, and it was like a word, which is why logarithms seem weird to people because it's like a word, but it really is just a symbol. It's directions that tell us to do something. And I'm going to show you how to do that on your calculator as well today. But this is what x equals. It's log base 2 of 9. Log base 2 of 9. That's how I would say that. Log base 2 of 9. But that's the answer. So that's what's new today. Now, this would not be something I could do in my head. We're going to start with ones that we can do in our head so we can see how logarithms really work. And then you'll also be able to do other ones that you can't do in your head with your calculator, okay? So now I'm going to go to our actual notes. And we're going to start with our first example, which is 2 to the x equals 16. Now, you should be able to tell me that answer. Do you know the answer, Jackson? It is 4. Yeah. So you should be able to tell me the answer. X is 4. But I'm going to show you using logarithms how it works. So this is a base of 2. And when we do logarithms, if we have a logarithm with a base of 2 of a base of 2, these are inverses and will cancel out. But if I do that, I have to do it to both sides. So I have x equals log base 2 of 16. Now I'm going to show you how the logarithm works. This is not exactly, but this is really, really closely related to what we did in chapter 5. 16 can be reduced down to a power. 16 is something to a power. What's 16? What to what? It's 4 to the second, or even further down, to the fourth. So I'm going to rewrite 16 as 2 to the fourth. I just took 16 and I rewrote it as 2 to the fourth. Now I've already told you, if I have a log base 2 next to a base of 2, they undo each other. So what's left? X equals 4. Okay, we already knew that answer the whole time, but I'm showing you how I get the answer using logarithms. So logarithms undo bases. That's what they do. So here's the next one. I have an exponential. This is an exponential, and my x is in the exponent. I need to get it out of the exponent, which means I need to get rid of the 3. So we are going to log both sides. What base should be on my logarithm, this tiny little number, if I want to cancel out a big base of 3? 3, the same number. And you get to pick whatever base you want because you're doing it to both sides. You can do whatever you want to both sides as long as you do it to both sides. I'm just choosing something that is helpful to solving the question. So log base 3 of 3 cancel, and I get x. On the other side, I'm going to do what I did above with the 16. I want to think about what is 81, but kind of reduced down to a power. What makes 81? Did this in our last chapter. Jackson. 3 to the fourth. It is also 9 squared, just in case anybody was thinking that but didn't say it. I am purposely using the 3 to the fourth so that log base 3 and 3 cancel. That's why I didn't use 9 squared. And what's left over is x equals 4. And isn't that true? 3 to the fourth is 81. I'm showing you the logarithms on ones that we can do in our head so that you know how to do it when it gets to the harder ones. Okay. Now this one is not asking us to solve, and the directions are not there. I really should type them in. I keep forgetting to do that. The directions are evaluate. Evaluate. Evaluate means find one value. Find one value. So this equals something. I notice that it is a logarithm with a base of 4. If this logarithm with a base of 4 has a 4 in this place, the 4s will cancel, not the 4s, the log base 4 and the 4 will cancel and we'll get whatever is left over. It currently does not say that. However, there is a way for me to take 1 over 16. Actually, let me say that again. There is a way for me to take 4 and make it look like 1 over 16. To take 4 and make it into a fraction, what does my exponent have to be? Do you know? It has to be a negative, exactly. So I'm going to put 4 to a negative something. That 4 to a negative is going to make it turn into a fraction. What's going to make it turn into 16? 4 squared, right? 4 to the negative 2 is equal to 1 over 16. So I just substituted 1 over 16 to 4 to the negative 2. These cancel, and when we evaluate this, we get the answer of negative 2. Hanero, how's that nap? If you guys are actively engaged, like writing things down, it's a lot easier to stay awake. Write the stuff down. This you've never done before. You're not going to get it the first time by not practicing. All right, the next one, log base 7 of 1. So what I want to do, and this is evaluate again. Log base 7. What I want to do is I want to substitute. I want to make 7 to something equal to 1. Can you guys tell me 7 to what power equals 1? What? 0. You've been memorizing. Good job. 7 to the 0 power, anything to the 0 power equals 1. So if I replace 1 with 7 to the 0, those are equal. So now I can cancel these out. My answer is 0. That's what logarithms are doing. They're finding the base 7 to a question mark is equal to the big number. That's what logarithms do. They're answering that question. They're finding what exponent. So this base can be anything you want. Almost anything you want. Now, there are 2 special logarithms that you will see. One of the logarithms, actually, before I say that, here is a form of how you will see the logarithm written. And this would be the exponential equation that's equivalent to this equation. These are the same. But x has to be greater than 0. This is a major thing. Okay, x has to be greater than 0. I want to show you that. I'm just going to show you that off to the side right here. Okay, I'm not asking you to do a logarithm right now. We can turn it into a logarithm. I'm not asking you to do a logarithm. I'm just asking you to figure this out, just, trial and error. What x value can I put in there that will make 2 to the and turn into -8? I have an answer. Amar. I can't make the 2 anything. I want to know what x, if I stick it in, equals a -8. What's an exponent mean? Like a squared or a cubed or a fourth. What's that exponent mean? Sophie? Right. So like this exponent here is telling me I'm going to multiply 2 times 2 times 2, however many times, I don't know, because it's an x. How many times can I multiply those 2's together to give me -8? Huh? I don't know who's talking. I can't tell. Oh, Sophie, sorry. Well, if I do 2 to the -3, what's that negative tell me to do? 1 over 2 to the 3rd. So I could get 1 over 8. Can I get -8? There's no possible way we could ever get -8 by multiplying together positive 2's. There's no way. So that's why right here, when we look at logarithms or we look at exponentials, x has to be greater than 8. So right here in this logarithm, anytime you have a negative number there, it cannot work. See where the x spot is? We can't have a logarithm of a negative number. And it's because of this right here. So you just need to remember we can't have a logarithm of a negative number. If we do, there's no answer. All right. So that's one thing special about logarithms. Another thing special about logarithms, and this is on your calculator, if you see just log by itself, right here, if you see log by itself with no tiny little base. And that is on your calculator. I can pull up mine and show you. It's right here. See that red button I just clicked? You see there's a log button by itself. Okay? If you see that, it's a common logarithm. That's what it's called. That's what it says in the paragraph. It's called common logarithm. And it always means a base of 10. And that's because we count in, like, what are those place values of 10? So when we do logarithms, this is the common one. This is like the way our number system revolves around, is tens. So this would be the same as log base 10 of 1 over 100. But we just don't write the 10. You know how when I do square root, I don't put a little 2 here, and we just know that's a square root? But when I do cubed root, I have to put the 3 there. It's kind of like that. Like the square root is just so common that we don't even write the 2. All right, what is the answer of this? 10 to the what makes 1 over 100? 10 to the what makes 1 over 100? What's one thing I know for sure if I'm going to make 10 into 1 over 100? It's going to be negative. That's how I make it into a fraction. How do I make 10 just into 100? Squared. So what is my answer for log 1 over 100? Aya, do you know the answer with my work? This is very new, so if the answer is no, you need to tell me so I can explain better. No? Okay, so when I have log base 10 next to a big 10, they cancel. So negative 2 is my answer. Yeah. Okay, there is another special logarithm, and we learned about E last class. That was the other thing we did, the E. Yeah. The natural logarithm looks like ln, and that button is also on our calculator. If you look on your calculator, it's right underneath the log button. There's an ln button. So that one's pretty important. We use that a lot. The ln button is the same thing as log base E. Log base E. That's what ln means. It's the natural logarithm because E is the natural number. So ln is the natural logarithm. Get it? N, natural, L, logarithm, ln. It's not what it really stands for, but it kind of works. So if I have ln e to the 3x, that's the exact same thing as log base E of e to the 3x. That's what ln e to the 3x means. Okay, so if I have log base E of E, these should cancel. But you're not going to see it written that way unless you change it. You're not going to see it written that way. You'll see it written the one underneath. So if I have ln of E, they cancel. They're inverses. What do I get for my answer? 3x, whatever's left over. So this is what we're going to do today. Is we're just going to do a bunch of this inverse stuff. For the most part, all I have left is just a ton of examples. Ready? Just going to go, go, go. If you feel like you're getting it, work ahead and check your answers. I'll probably pause at some point and walk around and see you try some on your own because I'm going to make it look so easy, but can you do it by yourself? Okay, so we're going to start with question A, and the directions are change from logarithmic to exponential notation. We're going to change notation. The directions are not solve something. Okay? So right now, I can see that this is in logarithmic form because it has the log there. To change to exponential form, we have to do something called exponentiate. Oh my gosh, I can't spell though. Exponentiate. There we go. We're going to exponentiate. Exponentiate, yeah. So when I exponentiate, I look at the base of my logarithm. And I give both sides a base. So I'm going to give both sides a base of 7. And I'm going to take both sides and I'm going to make both sides an exponent on that base I just gave. As long as you do it to both sides, we're allowed to do that. Ryan, do you need a stylus? Oh, okay. Have you done this stuff before? Okay. So you guys, what I just did is called exponentiate. Now, this is the opposite order that I had it above. When I have a base of 7 to the log base 7, they are still inverses and they cancel. And what do I get on the left side is 343. On the right side, I'm just going to write 7 to the third because my directions are not to simplify anything. They're just asking us to change forms. Right now, this is in exponential form. Seven to the third equals 343. You see how it's in exponential form. So these, oops, the original statement and this statement, they're equivalent. They're just different formats. I'm going to try it again. We are going to exponentiate both sides so you do not see the word log anymore, or the symbol, I should say log. What base is it when it's not written? It was in the paragraph above this. What base is it when it's not written? Tessa? 10. Log base 10. So to both sides, I'm going to exponentiate. New word, exponentiate. I'm going to put 10 to the log of 10,000. And on the other side, 10 to the fourth. So I exponentiated both sides. A base of 10 and a log base 10 undo each other. They're inverses, and we get 10,000. Again, we're not doing anything other than rearranging this and making it look different, but we're not like solving anything. We're not simplifying anything. We're just rearranging stuff. We're learning how logarithms work. Okay, the next one. I need to get rid of log base 3. So I'm going to exponentiate. I'm going to write that word again. Exponentiate both sides. What base should I use, Holland? What base should I use? So when I read this, I'm going to read log base 3 of 5. So did you hear me say the word base in there? So what should my base be? 3. Yeah, it should be the tiny little guy. So I'm going to put 3 to the y equals 3 to the log base 3 of 5. So 3 and log base 3 are inverses. They cancel. We get 3 to the y equals 5. And again, I'm not solving anything. I'm just rearranging stuff. Now we're going to do it backwards. This time we've got exponential form, and we're going to write it into logarithmic notation. Same thing we just did, only the other direction. So we're not simplifying, we're not solving. So I'm going to look at this one first, and I say this is 6 to the 0 equals 1, which is totally true. It's true. I don't have to like prove that or anything. We're just going to switch forms. Since this is exponential, I'm going to put it in logarithmic. I'm going to log both sides. I'm writing these phrases down because that's what you guys are going to say to me later when I say, what should I do? You're going to be like, oh, let's log both sides. Like you're going to know that phrase. Or let's exponentiate. Doesn't that sound so fancy and mature? It's like one of my favorite words to say. Okay. In math, not just like random. All right. So if I've got log, I've got to do log to both sides. I want to get rid of the base. What is my base? Sierra, what is my base in question A? 6. So I'm going to do log base, Sierra, 6 to both sides. See, I put log base 6 on both sides. Log base 6 of 6 cancels. We get 0 equals log base 6 of 1. You can rearrange it if you want. Typically, I'm lazy and don't. Oops, I forgot something. So either of these is fine. Writing them either direction is fine. Okay. So the next one. What's wrong? This is what? Hard? Hard. Hard? Okay. New. Oh, okay. So, Sophie, what base does this one have? 10 is the base. -3 is the exponent, right? 10. So I'm going to do log to both sides. What base of the log should I use? 10. So I'm going to do log base 10 to both sides. But just remember, if I do log base 10, I'm not going to write the 10. Okay, so I just did log base 10, but we don't write the 10. If I do log base 10, that cancels with a base of 10. I get -3 equals log base 10 of 0.001. And that's it. Yes, Jess. Why don't I have to put the little 10 down there? Because it's just like when I write the square root of 5, why don't I have to put the little 2 in here? Because we just know that means square root, because you've seen it so many times. So you're going to see this so many times that you just need to know that that one's base 10. Okay. All the other ones you got to put the base for. Just 10 you don't. Okay. So for question C. Warren, what is the base for question C? 16 is correct. So when I do my log to both sides, I'm going to do log little number what? What will be, what? I'm going to write log. Oops, I want to change my color. Hold on. To both sides of the equation, I'm going to log both sides. What tiny little number base should I make it? Yeah, 16. I just want to make sure that we don't have any questions on this stuff. I want to do a really good job of explaining it to you guys. That's my goal. Because I don't want it to seem hard. It's not hard. It's just new. So log base 16 and 16 undo each other. Okay. Simplify without the use of a calculator, or evaluate without the use of a calculator. Okay, so what you want to do is you want to change the big number to be the same as the base. Okay, so this first one is log base 5. So I want to make my big number to be a base of 5, but it has to equal 125. So that means I need an exponent. 5 to the what? 3? I hope that's what I heard there. And when I do that, the log base 5 and the 5 cancel, and we get an answer of 3. That's what the answer is, what that exponent is. That's the answer. So the next one, I have to change the big number so it is the same as the base. What is the base if it just says log? 10. If you say it, you're going to remember it more. So participate. 10. If you need to write it there because you're going to forget, that's fine. So what should the exponent be? 10 to the what is 1? 0. So then the log base 10, the 10 cancel. Our answer is 0. Log base 32. I need to change that 2 to say 32. But 32 to what exponent changes it into a 2? What, Jackson? Oh, you can. You can. It's just trickier. What do you guys know about 2 and 32? What do you know about those two numbers? Ashlyn, this is yours. What? They're both even. More. What did we learn in chapter 5? Tessa? 2 to the 5th is 32. So how do I make 32 into 2? What do I do to 32 to change it into 2, Tessa? Yes, it's like the 5th root, but we change that into an exponent of 1/5. Very good, Tessa. So if you need it to make it smaller, we're going to want a fraction exponent, which is what we were learning in the last chapter. Some of you haven't quite learned that yet, right? Some of us didn't do so hot. Some of us did awesome, but hopefully this will help reinforce it. Okay, this one already has log base 5 of 5. So those cancel, but what's our answer? Jacob, it is 1. Where are you getting that 1 from? There is an exponent here, and we never write it when it's the first power, but there is an exponent, and the answer is the exponent. So 1. All right, how about this one? Log base 3 And then we've got to make 3 into 1 over 81. So right away, if I have to make 3 into a fraction, what has to happen? I can only hear noises. I don't know who's talking. Nina, is that you? What? Negative. It's got to be negative. Now that makes it into a fraction. How does 3 turn into 81? To what power? Ryan, what power? Yes, 4th. So our answer for this is -4. Notice the answer each time is the exponent. Okay, we've got log base 2. So that means I need to make 2, the big number. But 2 to what power gives me -4? You can't do it. There's no answer for this. I think you say undefined. Because you can't have a log of a negative number. You cannot have a log of a negative number. You cannot have a log of a negative number. All right, these are solving. These are solving. I'm not going to solve. Well, no. I'm going to take what I was taking. I'm going to take what I was saying back. When I solve, I need to get x by itself. I always want to start with whatever's furthest outside of x. You kind of want to like think about it like something that has layers, and we're peeling away the layers until we get x by itself. So what's like the first thing we need to peel away? What's the first thing outside of x that I need to get rid of? What's the outest thing? Most outer thing? Ari, what is the most outer thing in question A that I have to get rid of? I need to get x by itself. What's the most outside thing? It's even outside of the parentheses. The logarithm, that's the first thing I have to cancel out. Get it to the other side. So how do I cancel out a logarithm? I'll go find it. I'll go back and find it. How do I cancel out a logarithm? How do I cancel out a logarithm? I exponentiate. If I need to cancel out a logarithm, I exponentiate. If I need to cancel out an exponential, I log. Those are inverses. They're just big fancy words. So I'm going to exponentiate. What base, what big number should I do to both sides? Ella, do you know? 3. So I'm going to do 3 to the log base 3 of x minus 3 equals 3 to the 5th. I chose to do the 3 because that cancels out log base 3. So what do I have left? X minus 3 equals 3 to the 5th is 243. Now what do we do to get rid of, or to get x by itself? Add 3. Okay, let's look at the next one. We need to get x by itself. This one's a little bit trickier because of where x is. We need to get x by itself, okay? For this one, I'm not quite sure what to do, so I'm just going to think inverses. If I see a log there, what's the inverse of a log? What do I do to both sides to get rid of log? My favorite word. Jacob. You're going to exponentiate. Jacob, do you know what base I need to use? I need to use x for my base. So I'm going to do x to the log base x of 343 equals x to the 3 over 2. Now I have the logarithm gone. So I have 343 equals x to the 3 halves. What I have here is a question that we were doing in chapter 5. We want this to say x to the first. Right now it says x to the 3 halves. Does anybody remember from chapter 5 what I can do to both sides so this does not say 3 halves, that it says to the first power? Do you remember, Jackson? Yes, but I'm not going to multiply both sides. I'm going to raise both sides to an exponent that is the reciprocal, 2/3. And then when I do exponent next to exponent, those multiply. So I get x equals 343 to the 2/3. Now I'm going to find that answer. 343 I've done already on this paper or on this file somewhere. 343 is a power. Does anybody know what 343 reduces down to? I've done it on here already once today. You're not going to see it unless you move your page around. Yes, Nina? It's 7 to the what? Yes, 7 to the 3rd. Okay. So now when I multiply my exponents here, the 3's cancel and I get 7 squared. And then 7 squared is 49. Oopsie, went too far. So 49. Question D. We have ln both sides. So this is a logarithm. ln, just to remind you, it was on the first page. ln is log base e. It's the natural log. So I have that to both sides. Since it is a logarithm, we are going to exponentiate. What big base should I use? Tessa. Oh, were there 3? Okay. I'll go back and do that in a second. How about, I've already started talking about this one, so I'll go back and do that one after this, okay? So right now I have ln. I need to cancel out this log base e. What should be my big number? I can't hear you. Just e should be the big number. I should do e to ln of 2x minus 3 equals e to ln 11. Oopsies, that should cancel on the other side too. So the e to the ln, they both cancel. And once I cancel those, now I have just a easy equation to solve. So if there's a logarithm, you exponentiate. What is the one that I skipped? Okay. So I'm going to stop talking for 30 seconds, which is going to be really hard for me. I'm going to stop talking for 30 seconds. See if you know what to do, at least to start this one. Okay, so you guys, for the most part, those of you that have been taking notes down, looks good. You said, this is a logarithm. I need to exponentiate. So 4 to the log base 4 x times x minus 12 equals 4 to the third. That cancels out the log. So then we have x squared minus 12x equals 64. X squared minus 12x minus 64 equals 0. Then by that time, I hadn't walked or I didn't see everybody past this. Some of you were like the people at the end had already gotten past this, but people at the beginning hadn't gotten that far yet. So when we have an x squared and a 12x, we can do quadratic formula. We can see if it factors. We're just going to solve it some way that we've learned this year. So this does factor to x minus 16 and x plus 4. And so I get two answers. I just want to remind you about something. Just be careful when you get like multiple answers like this, that we don't have log of a negative number. So if I put 16 into both of these x's, we'll be fine. What happens if I put negative 4 into this x, into this x? What will I get? Will I get a negative number? What, Sierra? It'll be positive because I'll end up having a negative times a negative and it'll be fine. Okay, just want to double check. So we have two answers for this, negative 4 and 16. Okay, so question E has an E in it. Question E, we have to get x by itself. We want to figure out what's the furthest thing away from that x. What should I get rid of first? Omar. Yeah, let's subtract the 5. So now I have e to the x plus 1 equals 15. What's the next thing we need to cancel out? I need to cancel out e. Right now, e is a base. It's exponential. So I have to think of a logarithm. I have to go to the opposite way. I got to think a logarithm. What log will cancel out a base of e? What log will cancel out a base of e? Jacob. ln is log base e. So, and if you guys are saying it, I just can't hear you very well because of the masks. I'm going to do ln of e to the x plus 1 equals ln of 15. So ln and e undo each other, and I get x plus 1 equals ln 15. And then subtract 1. And that's the answer. ln 15 minus 1. You can use your calculator to get an approximate answer for that because we have an ln button. So if you guys go to your calculator and just type in ln 15, close the parenthesis, minus 1. Make sure you can find that ln button. We get approximately 1.708. Does it seem hard still, or is it getting better? Getting better. Okay. Only have a few more. This is calculator now. This says to use the change of base rule to evaluate each logarithm to 4 decimal places. So let me write the change of base rule on here. If I have a logarithm of some base and some big number, to use the change of base rule, we do log of a different base of the big number divided by log of that same different base divided or of the base. I messed up my words a little bit there. We do log of x divided by log of b. Okay. And then this base right here can be any base we want it to be. That can be any base we want it to be. So because it can be any base we want it to be, I will either use log base 10 or ln, because there's buttons on the calculator. Those are the easiest ones to use. So for this first one, when we use the change of base, we are going, and I'm just going to do this with log base 10. I'm going to write log, and we do the big number first, 7 divided by log 5. Now on your calculator, type that in. Log 7 divided by log 5, enter. If you have the new calculators and you choose to do alpha y equals, you can have the fraction button. It's not necessary. You can also just do log, where's the log? Log 7 parenthesis divided by log 5. Did I type it in right? Was that the right one? Log 7? Yeah. So 1.2091. Okay, so the next one says use the change of base formula. So I will do log 3/7 over log 12. That's the change of base formula. And then that's what we can use on our calculator. Type it in the calculator. Calculadora. Use it. Fingers on calculator. Log 3/7, close parenthesis, divided by log 12. Enter. Got an answer. Negative 0.3 something. 410. Okay, I'm going to stop talking. On numbers 9, 10, 11, and 12, this says evaluate the logarithm. If you can't do it by hand, then it would be one that you can do in the calculator. But just because of time, I'm going to tell you, you can do these by hand. 11 and 12 are calculator. I want to see if you can find those answers by yourself. And then we only have one more thing to do. So you're we're evaluating it. This is what we were doing earlier. You're getting the easy ones out of the way. I do write hard. Oh, hands. Hard. Sorry. Good. You don't have to do that. You just, I mean, it's fine, but you don't have to do that. You're just going to do like 32 or 2 to the what is 32. Okay. So 9 and 10 are like the stuff that we did. Look back here. 9 and 10 are like these that we did earlier. This is 9 and 10. And 11 and 12 just using your calculator. Okay, undo these. I saw a lot of you writing this, which you absolutely did not need to do. You did not need to do that for this question, okay? This is when you're using the calculator. What you need to do for number 9 is you need to say log base 2 to the 5th. Those cancel, we get 5. What, hon? You mean does it matter if you do log 32 divided by log 2? Well, if you're using your calculator, this will work, but I don't know how you can do that by hand because like the logs don't cancel here. You would have to do log base 10 of 32, which you can't do without the calculator. Okay, and then this one is going to be the same way as number 9. We're going to say log base 27, then we have to make 27 big, and we have to put an exponent that makes it turn into 3. And so since 27 is going down to a number, it's making it smaller, we're going to use a fractional exponent of 1/3. Okay, so the answer for this is 1/3. These are on the calculator. Yeah. Log 12 is 1.079, and I think it just says 3 decimal places for this one. ln 0.75 is negative 0.288. 3 decimals. That's just on the calculator. Okay, last section. This should go fast. Fingers crossed. I'm not reading this because it's the same stuff that we just did a bunch of times in a row. If I am simplifying 10 to the log 4, what base is on this log up here? It's not written, so what base is that? 10. So if I have 10 to the log base 10, they are inverses. What's my answer? Question B. Log base 5 of 25 to the x. I want the 25 to be a 5. so that it can cancel with the 5, log base 5. So I'm just going to make it say 5, but that means I have to change my exponent. 5 to the what is 25? 5 to the second. Now that is already to the x power. So my next step would be log base 5. And when I've got exponents next to each other, I multiply them. And I get 5 to the 2x. Log base 5 of 5 cancel. 2x is our answer. So question 13. Question 13. Aya, I want you to look at question 13. What do you think the answer is? Where are you getting 8 from? Let me go back. 8 to the log base 8. It's just x, right? Thank you. Good. So this one, Ashlyn, what do you think you get? Correct. You just cancel out log base 7 and 7. We get negative 3x. This one's the hardest one because we've got log base 2, but we don't have a big 2 here. So I'm going to change this into a big 2. Ketsia, 2 to what power is 64? And that x is still there. So Ketsia, what answer do I get? 6x, perfect. Those cancel out, we get 6x. All right, and Ryan, e to the ln of 20. 20 is the correct answer because e and ln are inverses. See, not hard, not hard, not hard, not hard. You just got to recognize it. Takes practice. Takes doing your assignment and asking questions. Okay, so finding inverse functions. We did finding inverses in the very last section. Saves. Yes, Jackson, I'm sorry. Yeah. Why wouldn't it be 1/6? Because we're going from 2 to 64, so it's getting bigger. I'm not going from 64 to 2. Okay, like just think about the little number getting to the big number. Okay, find the inverse of each function. So going over the steps for finding the inverse, we just did this a few sections ago in section 5-6. The last section of chapter 5 was finding inverses. So step 1, switch x and y. Step 2, solve for y. And then we might need function notation. We might need function notation. Okay, we did that in chapter 5. Switch x and y, solve for y. So I'm going to do that with question A. Question A is f of x equals 6 to the x. I'm going to rewrite it as y equals 6 to the x so that I have a y there. Step 1, switch x and y. X equals 6 to the y. Step 1 done. Step 2, solve for y. So you guys are going to say, this is exponential. How do I inverse exponential? What do I do? What have we learned about today? We log both sides. Emma, I'm going to log both sides. What base should I use for my log? 6 is correct. So I'm going to do log base 6 of x equals log base 6 of 6 to the y. Log base 6 of 6 cancel. we get y equals log base 6 of x. That is the inverse solved for y. We do need to write this back in function notation because the original question has f of x in it. So I will change this to f inverse of x equals log base 6 of x. That is the inverse of f of x equals 6 to the x. One of them is exponential, one of them is logarithmic. Number 2. First, switch x and y. X equals ln y plus 3. Second, solve for y. Y is in a parenthesis, and outside of that parenthesis is ln. So that's a logarithm. What do we do to get rid of logarithms? We exponentiate, my favorite word of the day. So I need to pick a base that will cancel out that logarithm, which is the natural logarithm. E is the base. So I do E, and I'm exponentiating, so x becomes the exponent, equals E to the ln y plus 3. E to the ln cancel. So I get E to the x equals y plus 3. So y equals E to the x minus 3. This one started as y equals, so I don't need to put it back into function notation. Okay, question C, step 1, switch x and y. X equals log base 2 of y minus 1. Step 2, solve for y. So I'm looking at the right side where the y is. What is the furthest thing away? What do I need to get rid of first? Brooke, what do I need to get rid of first? The subtract 1. So we're going to add 1. Now we have to get rid of the log. What do we do to get rid of log? Evody. What should I do? I'm going to cancel out log. I'm going to get rid of log. So it's already a log. So I don't want to log again. What's the other thing? Exponentiate. Excellent. Do you know what the base should be? The base, the big number? 2. Very good. So you guys see how she said log at first? And I was like, well, there's already a log there. We don't want to do log on a log. No logs on a log. I don't know. So we're going to exponentiate. We're going to do 2 to the x plus 1 equals 2 to the log base 2 of y. 2 and log base 2 cancel. We get y equals 2 to the x plus 1. And then that didn't have to be rewritten as function notation. All right, last practice here. This one starts as f of x, so I will change it to y equals 5e to the x. I need to get x by itself. What's the first thing that I should do to both sides for question D? What's the first thing to start getting x by itself? Tessa, do you know?
Don't you switch X and Y?
Oh, yeah. First, I switch x and y. I'm going to ask the same question again then. Sorry about that. Tessa, thank you. How do we get y by itself? What's the first thing I should do?
Divide by 5.
Divide by 5. Good. So I've got x over 5 equals e to the y. Sierra, this is exponential. So what do I have to do to both sides? I have to do a log. But what should my base be for this log? Do I write log base e? What do I write instead? ln is correct. So I'm going to do ln for both sides. And ln of e cancels. So we get y by itself. On the other side, I have ln of x plus 5. This one has to be written back in function notation. So I will write f inverse of x equals ln of x over 5.